Hey guys, this is Joseph from StartDataEngineering.com. In this video, we will go over what Apache Kafka is, when to use Apache Kafka, and look at some common scenarios when you might want to use Apache Kafka. And we will finish off with a simple Kafka example where we will build a producer application and a consumer application and see how Kafka works. So let's get started. So first thing we would want to understand is what is Apache Kafka. Based on the definition on their website, Apache Kafka is a distributed streaming platform. So let's dive into what this really means. It means that you could have applications producing data, whatever the logic may be, and these applications are called producers. And Kafka enables reliably storing these messages, and also it lets consumer applications, which are applications that read those messages, to read those messages one at a time. It also offers order of data guarantee. What this means is if a producer sends a message at time 1 and it sends another message at time 1 plus 10 seconds, you can be assured that the consumer reading these messages will be able to read message 1 and then message 2. It also provides at least once delivery of data. What does this mean? This means if a producer sends data to the Kafka cluster, we can be guaranteed that the consumer will be able to read this message at least once. We say at least once here because there are cases where due to network failure or things like that, the consumer might read the messages more than once. There are certain techniques to deal with this issue. It depends on the use case. We will see some of these techniques in a future video. And the last thing Kafka does is it has support for running connectors and Streams API. Connectors are basically Kafka applications that run within the Kafka cluster that provide ease of connection to well-established services. There is a S3 connector, which basically is a Kafka application running within the Kafka cluster, which moves data from the topics to a specified S3 bucket. And there is an Elasticsearch connector, which moves data from a Kafka topic to Elasticsearch index. And then there's the Streams API. Streams API allow for writing programming logic on your messages, so you can process the messages within your Kafka cluster. So going forward, we will use the term message. It basically means the data that is sent into the Kafka cluster and being read by the consumer. So if you see on your left side, you will see this diagram which represents the basics of Apache Kafka cluster operations. So you have a producer that produces messages, and it pushes it to a ordered queue called a topic, and a consumer reads from that specific topic. There can be multiple topics within a Kafka cluster, but for this simple example, we consider only one topic. So now let's try to understand why someone would want to use Apache Kafka. In order to understand that, let's take a look at what is currently being done and why Apache Kafka may be a better use, may be a better tool in certain use cases. So currently most modern web applications are what we call RESTful services. What this means is you have a client service, usually a browser, sending a HTTPS request to the backend server. This HTTPS request is usually get, put, post, or delete, but there are more, but these 4 are the more popular ones, and excuse me, and they map to create, read, update, delete operations with your database. So a client sends this request, HTTPS request, to the browser, or sorry, to the backend, and the backend does some processing, whatever logic may be, and then it responds with a status code and sometimes data, actually most times data, that the client displays to the user. So you can see the simple image here where a client makes HTTPS requests and the backend server sends a response with a status code, and the client displays it to the user. So for example, if you actually right click on this page and go to inspect and network tab, you could and search for the post name, you could actually see the request that was made and the response that was sent. So you click on the headers tab, you will be able to see the request URL, what method it was, and the status code that was returned from the backend server. And if you click on the response tab, you could see the HTML. Basically, this tells the client, in this case Google Chrome, to display this HTML page. So let's look at some scenarios where we might want to use Kafka. So let's say we have an application which has 10 million users active, some amazing application, and we want to record user actions every 5 seconds. So if the user is idle, or if they're moving their mouse or hovering over a certain item, stuff like that. So this will produce about 12 user actions per user per minute, which translates to 120 million user actions per minute, because we have 110 million active users. So in this case, one key thing to notice, we don't have to let the user know that we have processed the data. We just want to store this information somewhere and process it at our own pace, depending on the project. So that's one use case. The second use case is that we have an application, may it be browser or some backend service, any application that's running some logic, and you want this application to be able to send data to 3 different applications. One way to do this would be to send 3 separate HTTPS requests to 3 separate applications. But an easier way would be to, depending on your logic of course, would be to push this message to a Kafka topic and have those 3 other applications read from that Kafka topic. This way you're just pushing messages to one place, and that is a single source for reading by the other 3 consumer applications. So one of the key things, actually let's go back here. One of the key things in these use cases is that we are basically storing the data somewhere and some other services are reading that data. So we do not expect an immediate response. In cases like this, Kafka is ideal. Yeah, so basically what happens in the first case is that you have your producers producing 120 million user events per minute, and they keep pushing these events into a Kafka cluster and a specific topic. And that topic, or that Kafka cluster, stores that topic within its disk. And let's say we are calling this topic a user action event topic. Right? So your producer keeps pushing messages to this user action event topic, and then you can have your consumer read from this user action event topic at its own pace and process data at its own pace. That way your producer is not waiting for a response for each data push. And similarly, in the second case, you can have your first application push a topic to multi-app event, push a message to a multi-app event topic, and then you can have your other 3 applications read from this one topic. That way your producer application is not having to push a single data 3 times to 3 separate applications. One thing to note here is that the producer can follow a fire and forget model or message acknowledgement model. So what is a fire and forget model? A fire and forget model is basically when the producer just pushes message to the Kafka cluster and it does not wait for any acknowledgement by the Kafka cluster that it has received the message. It just pushes the message and then it continues with its processing. This is useful if a few message losses are tolerable, and it increases and it prevents blocking of your producer, meaning your producer does not have to wait for a few milliseconds for the Kafka consumer to respond. But if you want to make sure all your events are delivered to the Kafka cluster, you can follow the message acknowledgement model, where your producer will wait for the Kafka cluster to respond with an acknowledgement of message received. Note here that it's waiting for the Kafka cluster to respond, not for the consumer. So you still are decoupled from the consumer processing logic. You just make sure that your message is being received by the Kafka cluster. So this is a popular image taken from the Apache Kafka documentation page. Basically, you can have multiple apps writing to multiple topics within the Kafka cluster, multiple apps reading from them, and as mentioned about, you have popular connectors connecting to databases, distributed storage such as S3, and also Elasticsearch. And you also have stream processors, which, if you notice, it's both reading from and writing to Kafka cluster. A common pattern with stream processing is that it reads one or multiple messages from the Kafka topic. It does some processing and pushes it back into another topic, which, depending on your logic, you can couple multiple stream processing logic together. So that's a common pattern, and that's why you see this double arrow here. All right, so let's get started with a simple example to understand how a producer produces message and a consumer reads that message. And in order to do this, we need to have Docker and Python 3 installed. I'll leave the links in the description below. You can install those from there. For Kafka, we are going to be using a popular Docker image called Wurstmeister. It's pretty popular and it's easy to set up. So let's clone that GitHub repo, which has the Wurstmeister. So this is the GitHub repo for Wurstmeister. You can just clone that. Okay, yeah, that's because I have SSL set up, so I'll have to do it another way. You can go here, Kafka Docker, clone, SSH, there we go. So now you will have your Wurstmeister Kafka Docker repo cloned. You can go into that. So when I'm using someone else's repository as a starting point, I generally remove the Git repo. So now you don't have a Git repo associated with this folder. Alright, the first thing we want to do is we want to modify the docker compose.yaml file. So if you take a look at that, by default it comes with the minimal parameters, but we want to change these Kafka metrics environment variables so that it allows communication between processes outside the Docker container and within the Docker container, and also between Kafka container and Zookeeper. A quick note about Zookeeper. Zookeeper is another Apache open source project which does cluster management, so it lets you know what nodes are available, what the memory is available, what the disk size is available in each node are. So let me just copy this. Gonna remove docker compose.yaml. So updated the Docker compose.yaml with these environment variables that allow for communication. And now let's start our Docker containers. Okay, I make sure I'm not running any Docker containers. Docker compose up -d. So Docker compose up basically goes through your Docker compose YAML file and starts all the services specified. And this -d lets the Docker compose CLI know to run these Docker containers in the background. Let's take a look at the containers running. Sweet. So you can see the Docker Kafka container and Docker Zookeeper container running, and the ports that are exposed. Alright, so now that we have our Docker Kafka container running, we can create two Python scripts, a producer script and a consumer script, to interact by sending messages to a Kafka topic. In order for Python to interact with Kafka, we need a specific Kafka library. So I'm gonna pip install Kafka 3. I already have it. So we are going to be using Python 3, and that's why I use pip 3. You can use whichever version you have. Alright, one thing to note here is topic creation. So by default, depending on this variable, auto create topics enabled variable, you will be able to automatically create topics. So what this means is, if you are writing a producer application and you have the auto create topics enable option set to true within the Kafka container, whenever you write to a topic that doesn't exist, Kafka will automatically create that topic for you. And one thing to note here is that you have something called a broker. Basically, a broker is a machine within the Kafka cluster. So you can have multiple brokers per cluster. Setting this will set it true across the entire cluster. But just know that a machine within the Kafka cluster is called a broker. Alright, so let's write some code. The first thing we are going to be writing is a user event producer. Let's call it user event producer.py code. Pretty straightforward. So let's say insert from datetime. I'm using the datetime library because I'm creating a datetime as part of the message to be sent over to the topics. And we are going to be using JSON library to serialize our message into a JSON to be sent over to the Kafka topic, and then on the consumer side we will deserialize it. Serialization is a common technique in data passing. People usually call this DTO, or data transfer object, where you have your data and you serialize it using a serializer that is accessible across multiple languages. So for example, if you serialize it as JSON, you can use Scala as your consumer and deserialize it there. So serializing allows for interoperability across different languages. So that's what we are going to do here. And then we need a Kafka producer. So Kafka producer, and then we're using the random library, we're using time library, we are using UUID. UUID stands for universally unique identifier, which creates a unique ID each time it's called. This is going to be unique across all the IDs created. And let's set a event type list for our example. So I created this to simulate a user browser event. So they buy something, they sell something, they click on a button, they hover over a button, their mouse is idle for 5 seconds. something like that. Then we create a producer object. So producer object is Kafka producer object. So here you can see value serializer. So let's see what this is. So basically it's a lambda function, which basically means it runs on each message at a time, and it dumps our message into a JSON structure, and it encodes it as UTF-8 characters. And we say bootstrap servers is localhost 1992. So localhost 1992 represents the Kafka endpoint. So we're asking the producer to communicate to this port. All right. So let's create a topic. Let's name this events topic. All right. So let's start with a simple send events method. So let's say define send events and naive loop while true. Let's say data equal to produce event. We are going to create that method later, and we just sleep the process for 3 seconds just to simulate a real user environment where the process is you're doing something else, and then takes 3 seconds. It's just a simple simulation of that. Then what we do is we use the producer object that we created up here, and we send to the topic name the data that we just created. So let's go ahead and create the data, and let's create a function called produce event to create this data. It's a simple dictionary with an event ID, which is a unique identifier. And then a event date time, which is the current date time but formatted in year, month, day, hour, minute, second format. And lastly, event type. It's a random pick from this event type list. So random choice event type list. Yeah, so that will produce a unique event each time. And yeah, let's make this into a script. So we say if name equal to main, send events. Alright, so basically when we enter the script, it will trigger the send events method, which just goes through an infinite loop, sending data to this topic every 3 seconds. Right, and go ahead. Now let's take a look at the consumer. Let's call it vim user event consumer.py. Again, here we need JSON library to deserialize the serialized data that we sent from the producer, and then here we import the Kafka consumer module. Again, topic name, we had it as events gets topic, events topic, and let's define the consumer object here as a Kafka consumer topic name. Alright, so here let's look at these things one at a time. auto offset reset equal to earliest. So what does this mean? This means that when we are reading from a topic, start reading from the earliest available message in that topic. So this will always start from the first message available in a topic. And group ID, let's copy this over. So what is group ID? In most cases, a consumer runs as part of a group. So when you have multiple consumers running in a group, assigning it a group ID will help the Kafka cluster manage the group level configuration. We will see it in a little bit in more detail in a little bit. And then let's copy over the Bootstrap server, again communicating with the cluster, and value deserializer. So if you remember, in the producer we serialized it, and in the consumer we are deserializing it. It's basically it. So that's the consumer, and we just have a naive method that just constantly checks in, it gets the message from the consumer and prints it out. Just gonna copy that over. In real life, this will be a more complex logic, but because this is a toy example, just keep it simple. So that's pretty much it. So now we have a producer and a consumer. Let's look at these metrics in a little bit more depth. So offset, what exactly is an offset? So if you look at this image, you can see that messages start from 0, 1, 2, all the way up to 10, 11, 12. And offset is basically, you can think of it as this number. It's the order that the number that represents the order in which the messages came in. So why is this important? Right? So let's assume your consumer is running and then it crashes, some exception or overloading, whatever it may be, your consumer crashes. And if we restart the consumer, because we have set this auto offset reset to earliest, it'll start reprocessing all these messages that were already processed. But in most cases this is not ideal because you are essentially duplicating the data and doing work that has already been done. So what you do is you set this auto offset reset to something called latest. So what that will do is it will figure out how many messages were processed and then start reading from that message that has not been processed. So for example, in this image, excuse me, you can see consumer A has read up to 9, and if it crashes and comes back up and we had set the auto offset to latest, it'll start reading from 10, 11, 12, so that it's not reprocessing messages that has already been processed. And group ID, as mentioned before, it's basically a consumer group ID. We will see how this offset is being managed, like where this offset information is stored, below soon. Alright, so now let's go ahead and start it, right? So let's start the event producer. Producer. So I'm starting it with an ampersand sign. Basically what this does is this runs the producer in the background. Oh, there's an issue. So it says there is an issue with Bootstrap. Okay, I think I didn't type it right. So let's take a look at that. User event producer. Okay, yeah, it's my bad. I made a typo. It's supposed to be Bootstrap servers. So after we have started the server or the producer, we can start the consumer, which is Python user event consumer.py. It'll start reading messages that are being sent by the producer every 3 seconds. So you can see actually these messages being printed out to your screen. Let's stop this using Control C, and let's also stop the producer using the pkill command. Alright, so now we have seen the producer producing some messages and pushing it to a topic, and consumer reading those messages and just printing it out to the screen. Let's actually look at where these messages are being stored within the Kafka container. So if you say docker ps, you can actually see your containers that are currently running. So you see a zookeeper and a Kafka container. Let's SSH in, or actually it's not SSH. Let's bash into the Kafka Docker container. So basically docker exec-it is docker execute a command interactively, and this denotes the docker ID, which will translate to this, and then bash is so that you can open the bash prompt. So we are inside the Kafka Docker container now. Kafka ships with a bunch of scripts in the bin folder in its home directory, which you can use to look at the configurations, list topics, view the contents of the topics, and so on. So let's list all the topics in our Kafka cluster. Give it a few seconds. Excuse me. So you can see two topics here. Consumer offset is an internal topic within the Kafka cluster, which stores the offset of each consumer. So remember earlier we saw that every 5 seconds, or in the background, the consumer lets Kafka know which message it has processed, the last message it has processed. So that information is stored in consumer offset, and event topics is the topic that we just created. Let's actually use this consumer command to look at the messages in events topic. It's pulling out the data. Alright, so there are tons of messages. You could see them all here. So this is very helpful if you want to debug an issue with the consumer or producer not operating as expected. Control C out of it, and you can exit the cluster or the container using exit command. Alright, so what is actually happening in consumer offset? So what actually happens in the background within a consumer is that every 5 seconds, this is a default value set using auto commit interval millisecond configuration parameter. So every 5 seconds, the consumer lets Kafka know the latest offset it has processed. So that information is stored in the consumer offsets topic that we saw. And this feature is by default set to true, and this feature is called enable auto commit. Basically means the consumer is letting the Kafka cluster know the latest message that it has processed or read. And again, a thing to note here is Apache Kafka is a distributed system, and as with most distributed systems, it stores data in partitions. So it chunks up a topic into multiple partitions, usually 3, and stores them within different nodes of the cluster, so that in case of a node failure, you can easily recover the data. This is a very common pattern used by like Hadoop and Spark and all the distributed data storage systems. So you can see here the same topic is being copied across 3 partitions, and when a write occurs, it's copied over to these 3 partitions. So let's go ahead and stop our Docker containers. You can just do a docker compose.yaml, which will stop all the services that were part of the docker compose.yaml file. Alright, so let's do a quick recap. So in this video we saw what Apache Kafka is, from producer and consumer and topic, and what are the use cases where Apache Kafka really shines, and some common or foundational Apache Kafka concepts like what is a producer, what's a topic, what's a broker, what's a consumer, what's an offset, and what auto commit means. If I had not mentioned broker, a broker is basically a node within the Apache Kafka cluster. So you call each node, you can think of each node as a individual broker. It's more than a node, it's more the virtual machine. But for ease of understanding, you can start off as considering it as a single node within the cluster. Again, there are more advanced topics like partition size, partition function, like how is the partition clustered among different nodes, and connectors and streams API, which we will cover in a future video. And I hope this article gives you a good introduction of Apache Kafka, what it is and why people use it, and more importantly, when not to use it, and hope you can make good use of this knowledge. And if you like this video or if you found it helpful, please like and share, and do subscribe to the channel for future instructional videos. Thank you.